All right, welcome to lesson 1 of mod 3. In this lesson, we're going to talk about area formulas. And really this first day is to either reacquaint you with area formulas you knew before or introduce you to area formulas you've never seen. And the only point of today is know how to use a formula and memorize as many of them as you can. So there's not a lot of understanding that's going to be going on today. We're not going to teach you anything that's crazy difficult. It's just, hey, here's a bunch of formulas, use them correctly. That is the purpose of today. So you're just going to copy formulas down as we go. I'm not going to explain them yet. We'll do some practice, and then you're going to do some practice in class. So let's start. Rectangle. Everybody should know the area of a rectangle is base times height. End of story, done. Triangle. The area of a triangle is 1/2 base times height. Now, I always tell students, memorize it as 1/2 base times height instead of base times height divided by 2, because many people forget to do the divided by 2 step. So if you always memorize the formula as 1/2 base times height, then you'll never forget about the 1/2. Yes, it's still the same if you do it both ways. Parallelogram. You may not have seen a parallelogram before, but believe it or not, the area of a parallelogram is the same as a triangle, base times height. That's it. Now, if we have a trapezoid, the area of a trapezoid will be explained to you more in lesson 2, but the trapezoid area formula is h/2 times b1 plus b2. You take the two parallel sides, the bases, add those together, that's b1 and b2, and then you take the height and multiply by h/2. h/2 b1 plus b2, just a formula. A rhombus. Rhombus formulas are defined by their diagonals, and the area of a rhombus is 1/2 the product of the diagonals. 1/2 d1 times d2. A kite also has perpendicular diagonals, as does the rhombus, in case you forgot, and has an area formula that's the same as a rhombus. Area equals 1/2 the product of the diagonals. All right, last but not least, we've got a circle and a regular polygon. A circle, the area of a circle is pi r squared. You should know that. The area of a polygon is completely new to you. The area of a polygon uses P and A, where P is the perimeter, and A is what's called the apophthegm. Okay, it's the apophthegm. The apophthegm is the perpendicular distance from the center of the polygon to the outside edge. Okay, center to the edge, perpendicular distance. Perimeter, apophthegm. The area is 1/2 AP. The area of a regular polygon is 1/2 AP. Area, perimeter times apophthegm divided by 2. And last but not least here, we've got what is perimeter and how do you find it? Well, perimeter is the sum of the lengths of all the sides. Okay, and you should know that. There's perimeter formulas technically, but nobody cares. You just find all the sides, add them together. If you can think of an easier way to do that, absolutely do it easier. All right, so now, if I remember how to do this here, I want to do a side-by-side view here so we can look at all of our area formulas at the same time. Look at that, that worked out well. All right, so when I go here to do some basic practice, we're just going to reference this sheet on the left-hand side and answer things on the right-hand side. So if you want, when you're looking, you don't have to flip back and forth, you can just kind of watch me on the left. So if I wanted to find the area of a parallelogram, I'm going to look over here and say, all right, parallelogram is where? I can't use that pen apparently. Parallelogram is over here, and the area of a parallelogram is base times height, so I come over here. Now the question is, what's the base, what's the height? Well, the base for a parallelogram would be usually the bottom, and if you're not sure which to use, you want to use whatever side has a perpendicular drawn to it. So the area of this parallelogram is 20 times 12, which is 200. All right, done. Area of a triangle. Area of a triangle. Triangle is 1/2 base times height. So the area of this triangle is 1/2 the base. Well, the base is the 3 and the 4, so it's 7. And my height is 4. 1/2 base times height is 1/2 of 28, which is 14. Now, what about units? Technically, you don't ever have to give units unless you're told to, but we should. So this would be 240 square centimeters, or centimeters squared, however you want to say it. And this would be 14 square meters. All right, we're going to skip over the next one. We've already done triangles. Let's come down to this kite. So on number 4, we have a kite. Kite formula's here. 1/2 the product of the diagonals. So my area is 1/2. This diagonal, 2 and 5 makes 7. And this diagonal, 3 and 3 makes 6. So 1/2 of 42, which is 21 square meters. Here's one of those trapezoid-y things. Well, tell you what, let's come over here. I'm going to do the harder trapezoid with you, number 6. So number 6, if I need a trapezoid's right here on the left. H over 2, B1 plus B2. So if I do my area, it's H over 2. I don't know H yet. It'll be right here. But H over 2, B1, 5, plus B2, 7. Now I need the height. I need the height. Oh, wait, they gave me the 60-degree thing right here. Okay, so if I wanted to find this height, I'm going to make this a little bit bigger here. If I wanted to find this height, I would have to say, well, this is 5, so that means this is 5. And if the whole thing is 7, that guy's 2. So I have a right triangle here with a 60-degree angle, and one side length is 2. Now, you did 30, 60, 90 triangles a while ago, so you could either do SOHCAHTOA to find your height, or you could do that whole idea of a 30, 60, 90. Remember when you had 30, 60, 90s, and you had the side across from 30 was A, the hypotenuse was 2A, and the side across from 60 was A root 3? I'm going to use that. If you don't remember that, you can do SOHCAHTOA. But X right here is going to be 2 root 3 because of the rules with 30, 60, 90. So if I want the height here, when I do H over 2, I'm going to do 2 root 3 over 2 times 5 plus 7. And then when I multiply that, my 2's would cancel, and I would end up with 12 root 3, or its decimal equivalent. Okay? Again, all I'm doing is looking at the formula, using the formula, looking at the formula, using the formula. So I get to rhombus, 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 rhombus. 1/2 D1 times D2. All right, so 1/2 D1 times D2, okay? Well, they're telling me this little section right here is 12. Obviously, you can't really see that on the screen right now, but on your paper, you should be able to see it. So this little section is 12, which means that section is 12. So my first diagonal is 24, but I don't have my second diagonal yet. I need this thing. Well, if you remember, diagonals of rhombuses are perpendicular. So this guy right here is a right triangle with a base of 12 and a hypotenuse of 13. And I just need this piece. Well, if I need that piece, I could do Pythagorean theorem. And if I did Pythagorean theorem, I would have, I'm going to do it right next to it, x squared plus 12 squared equals 13 squared. So to solve for x, x squared is going to be 13 squared minus 12 squared. And in the interest of time, just trust me, that's 25. That means x equals 5. So that means this equals 5. And that means this equals 5. And so does that, because the diagonal in a rhombus is bisected. 5 and 5 makes 10. So the area of a rhombus is 1/2 the product of the diagonals. If you don't have both diagonals, you need to find them. So we did that. 1/2 of 24 times 10 is 120. Circle, pi r squared. Well, that means I need the radius. I have a diameter of 6, which means I have a radius of 3, and the area would be pi times 3 squared, which is 9 pi. Or you could use its decimal equivalent. Now, at the top of this page, I said nearest tenth when appropriate. I don't have a calculator on the screen right now, so we would need a calculator to do that. So for like number 6 here, when we got this decimal radical answer that could be a decimal, and number 8 here, where I could get a decimal, you should plug that into your calculator and get a decimal answer. We're just not doing it now. Yes, it's time. Anyways, last but not least, I've got a decagon, a regular decagon, which is a regular polygon. So the area is 1/2 AP. Well, A is the apothem, The apotheosis is this guy right here. So my area is going to be 1/2 2.3 times the perimeter. Well, the perimeter goes all the way around. So if this side is 8, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides in a decagon. One side is 8, 10 sides would be 80. So I just need 1/2 of 2.3 times 80, which is going to be, hang on, I need to use a calculator off screen here. 1/2 2.3 times 80, I'm getting 92 is the area there. All right, so long story short, if I come back here and look at, oh, what is happening? Let me switch. If I came back and looked at all of these, all I did was use the formulas on this page to get the answers on that page, all right? So let's see, we're at about 11 minutes now. I want to do a couple more with you, and then we will stop. So let's say I come over here, and it says use the area of a parallelogram shown to find FC. Well, what do they mean by that? Well, fine, this is the area of a parallelogram. The area of a parallelogram is base times height. So if I have this parallelogram, fine. Base times height, my base would be 10, and my height is 12. So I have an area of 120. That number seems to come up a lot. Well, what does that have to do with FC? Well, here's what it has to do with FC. Watch this, I'm going to be really creative right now. So if I want to figure out what that has to do with FC, I'm going to crop this. Ignore this line, it's just a little artifact in the cutting and pasting process. I'm going to take this and I'm going to say, well, what if 10 wasn't the base? What if, oh my God, what did you do? I turned it. What if 13 was the base? If I want to do 1/2 BH with, not 1/2 BH, pardon me, if I wanted to do B times H, again, I have a base of 13, but I need a height. And my height is this distance right here, FC. Well, if you really think about it, isn't the area of a parallelogram just the same no matter how you turn it? So what I could do is say B times H for one turn equals B times H for another turn. So 10 times 12, when it's sitting on the 10, should be equal to 13 times FC for when it's turned and sitting on the 13 is the bottom. The area should be the same no matter which base and height I use. So 120 equals 13 times FC. So if I do 120 divided by 13, FC is 9.23 approximately. Now, what was I asked to round to? I don't remember. 9.23, it says to the nearest hundredth. That is the nearest hundredth. Fantastic. So 120 equals 13 times FC. And we got FC is 9.23. All right, let's see. I'm going to skip over number 2. You can do that with your teacher tomorrow. And I'm going to jump down to number 4. This will be our last one to do together. Find the area of the equilateral triangle. Round your answer to the nearest tenth. All right, well, the area of a triangle is supposed to be 1/2 BH. And they tell me this is equilateral, so I know all of these are 8. So I have my base, but I don't know my height yet, okay? So whenever you're using these formulas, write down what you know and then figure out what you need. So I need height. All right, well, if this is equilateral and I drop the height down, it's going to split this 8 up into 4 and 4. And now I have a happy-pappy little right triangle over here where the base of the right triangle is 4 and the hypotenuse is 8. So 4 squared plus x squared equals 8 squared. And if you want to trust me on this, this is another 30, 60, 90. And the height here I can get from Pythagorean theorem or from the 30, 60, 90 rules, whatever you want, it's up to you. I'm going to start with Pythagorean theorem and finish with Pythagorean theorem. So if I take 64 minus 16, 8 squared minus 4 squared, I end up with 48. And if I square root that, I get 6.9. It says round to the nearest tenth. Well, here's a little known fact. If you're supposed to round your last answer to the nearest tenth, that means you want all your little subsequent steps to get you there to be rounded further. So I'm going to write this as 928 because that's what the decimal comes out to be. Again, I'm sorry that there's not a calculator on the screen for you. But this will be x equals 6.928. That is my height. So that's going to go here. And then I'm just going to type all that into the calculator and get 1/2 times 8 times 6.928 equals 27.712. They wanted us to round to the nearest tenth. 27.7. All right. So there you go. There's area formulas. Know them, love them. Come to class tomorrow ready to talk about them. Let's see, and we need a stupid joke this time. What stupid joke should I tell this time? What keeps a tree from moving? Square roots. Ha, 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 ha. It's not that funny, but there you go. Bye.